Hi, and welcome back to a Frugal Tech channel. After all these months, I finally had an interesting idea for a video, so, well, here I go. Phone chargers. Yes, that was the idea. I mean, you surely have some of them laying around in your house, but can you really trust them? Do you know that using a bad quality charger repeatedly could send your phone and other devices to cyber heaven faster? I gathered 15 different chargers that were scattered around my house, both branded and unbranded. An iPhone charger, 2 iPad chargers, this Nokia charger here, an Asus charger, a Samsung charger, this Sony engineering sample, very mysterious charger, this Huawei charger, this Vinsik, what a strange name, charger with 2 USB ports, this Varta charger, this unbranded USB TC02 charger, this HuntKey charger, Aukey Qualcomm Quick Charge 2.0 compliant USB charger, and also those 2 travel adapters which actually do not have a brand. One of the 2 can provide power to 2 USB ports, the other has just 1 port, but they are cosmetically identical. Also, I decided to use a couple of power banks that I had laying around to simulate 2 different loads. This Anker power core here will be our 2 amp load. Meanwhile, this... Wait, don't run away. Stay here. Good. Meanwhile, this older MIPO power tube will be our 1 amp load. If a phone charger won't be able to give 2 amps to our Anker power core battery, the current provided will be lower. We'll see. Last but not least, I needed some stuff for measuring everything. Since I didn't want to tear my chargers apart and I don't have the money to buy an oscilloscope, I decided to use this USB multimeter here to measure voltage and current. It's not the best decision, but it will do. I also used a wattometer to measure the power consumption from the wall. You can find both of these tools on Amazon or many other websites. After a lot of measurements, which were not as fun as I thought, here are the results. Let's look at the voltages first. We can see that every charger has its own voltage for each scenario. I measured the maximum and the minimum values, so we can have a pretty simple but effective idea of the fluctuation of the voltage. It is safe to assume that if the voltage doesn't exceed 5.25 volts and is over 4.75 volts, the charger is not going to hurt our phone or other devices in any way at the given load. If the voltage is 250 to 300 millivolts over or under 5 volts, the charger can be a bit risky to use. If the voltage is over 5.3 volts or under 4.7 volts, I wouldn't touch that charger with a 10-foot pole. We can see that the Huawei charger fails massively the 1 amp load test with voltages as low as 4.45 volts and doesn't do much better in the 2 amp test, and the Samsung in the 2 amp test is not performing okay. The unbranded chargers show some problems as well, because the Varta and the USB TC02 fail both tests, especially the Varta, with its voltage going as low as about 4.1 volts in the 2 amp load test. Also, even the Aukey charger has a quite dangerously high voltage on the 2 amp test, but this could be due to the fact that the Qualcomm Quick Charge 2.0 compliant charger can operate at 5, 9 or even 12 volts. We can also notice that in the 2 amp load test the current is not always very similar to the rated value, especially with the Varta and the USB TC02 chargers, which are rated for 1 amp only but deliver up to 2 amp. I don't think that's very good for your device safety. When we take a look at the efficiency, which I measure dividing the mean DC power output by a mean value of the measured power consumption, we notice that only the already problematic Varta and the USB TC02 had an efficiency under 50% in a test. Also, the most efficient charger is the Aukey, with an efficiency value of about 82%, even if its voltage was a bit too high in the 2 amp test. Some other chargers go between 65 and 70% of efficiency in one or both tests, but it's nothing to be worried about. Finally, if you want to find the chargers that pass my test with green marks, we can see that the Nokia AC60E, the Vinsik VSCW205, the Apple A1357, the AND key HK80060501003B, the Sony CP82, and even an unbranded travel charger with 2 ports have both a safe voltage and an efficiency of over 70%, so I guess that even a non-standard charger can be okay too. Thanks for watching, I hope this video was helpful. If you want to see all the data gathered from this experiment, you can download the file from the link in the description. Subscribe to the channel if you want to see more stuff, and remember to stay frugal.